Okay, now we're going to look at this two-way tables and how we calculate probabilities when given two-way tables. So here's an example. The table shows the results of a poll of 50 randomly selected students who were asked whether they prefer to watch hockey or football. Find each probability. So let's look at this table a little bit. We said that there's 50 people. So if we have 18 boys prefer football, 18 boys prefer hockey, and there's no overlapping, right? So that's 28 in total. Oops, sorry. That's 28 in total amongst the boys. Now, if we have, that's 28. And then for the girls, we have 6 girls into football and 16, and that's 22. So if I add the two together, that's how I get 50 people. That's how we understand this table. Now, in order to calculate the probability, I want to see the probability of those who preferred football, given that I already know that they're girls. So like I said, there are 22 girls in total. So my denominator is 22. And how many do they have like football? It's 6, right? So it's 6 out of 22's student girls who like football. So that's 3 in over 11. Okay? Now, same thing for all the people who play hockey. So this time we look at it horizontally. How many people are into hockey? It's 10 and 16. So that's, if I add it together, is 26 people in total. And then number of boys is 10 boys are into hockey, which is right here. So it's 10 over 26, which is 5 over 13. Okay, I'm going to skip number 5 and I'll focus on number 6. The table shows the result of a poll of randomly selected juniors and seniors who were asked if they attended prom. So here's the table. Now let's look at the questions. I'm asked to calculate the probability of a junior that did not attend the prom. So the junior that did not attend the prom is 56. And the probability is basically asking me out of the whole school, what's the probability of a junior who did not? So I have to add all the juniors and seniors in the school together. So that's 28 plus 56 plus 97 plus 19. And I would have 56 over 200, which is 7 over 25 after I simplify it. Okay? Now, probability for those who did not attend a prom, knowing that they are a senior. Now, the total number of senior is 97 plus 19, which is 116. And those who did not attend, the seniors who did not attend, is 19. So it's 19 out of 116. And then I'm asked to say, to calculate what is the total number, what's the probability of a junior amongst those who attended prom. So again, this happens first. For those who attended prom, that's 28 plus 97, that's 125. And the juniors who went were 28 kids only. So it's 28 over 125. Okay, it takes a little while to get the hang of it, but once you pay attention to how the questions are asked, look at all of these. I'm going to use red. Look at this bar. It means, in the earlier video we said, it means given, right? If it's given, whatever is behind given happens first. You calculate that, and then the denominator is whatever in front of the given. It's that easy. The rest of it takes some English comprehension, but that's why math peoples are math people. We don't like the the ambiguity in the English language sometimes. Okay? Now let's look at frequency tables. There are two kinds of frequency tables. This is one of my favorite, marginal relative frequencies. Very quickly, you're going to find out what frequencies is all about. But marginal relative frequency are found by totaling each row in the column. So if you look at this, has an extra column on the side and at the bottom that totals up each column and each row. That gives you a sense. Okay. A frequency is basically the value in each category divided by the totals. It's the percentage of the total. That's what it is. It's a easy enough concept. So let's look at this problem. The table below shows the number of first class and coach class passengers on a plane who checked one bag, two bags, or no bags. Find the joint relative and marginal relative frequencies, and then find each probability. So in order to calculate that, I have to know what is the total number of passengers. If I add all of this together, 16 plus 12 plus 2, 1, 2, 30, 90. So I have 160 in total passengers. Okay. So to calculate frequency, I take first class passengers who checked in two bags, that's 16 of them, divided by the total, 160. So I have 0.1 as my frequency. Then I do the same with all of it. I have 0.075. Excuse me. Oh, that's 160. And 0.0125. And I add them all together. This is 0.1875. Okay, in other words, 0.1875 of the total, which is also 18.75% of the total passengers are in first class. Okay, so I'm going to do the same for everything in the coach class as well. So it's 52 divided by 160. I have 0.325, and I want you to do the rest of it, but I'm going to write the answers here. Double check your answer. Do not just copy. I want to see the actual process, regardless you put in a calculator or not. Okay, and now to calculate the total, if I want to say the total number of passengers in both first and coach class that checked in two bags, I simply add the two together. Oops, that's 0.1 plus 0.325. Obviously, it's 0.425. For the same reason here, I add it horizontally. Now, if I add all three together, I should have 1. Either I add all three in the column of total, or I add the 2 in the rows at the bottom. I should get to my final 1 altogether. Okay, frequency table is really not hard. It's very easy to read. It gives you a big picture, so it simplifies things a lot for us. So use it well. Now, let's look at some of the examples at the bottom. We have to calculate the probability of a coach class passenger that did not check any bags. So this is very easy. If we look at coach class that did not check any bag, and that would be the 18, I think, 18 passengers. And the probability is right there. It's 0.1125, which is 11.25%. Okay. Now, second question. Probability of a first class passenger that checked at least one bag, meaning those who check one bag and two bags have to be together. So this is first class. So it's 16 passengers plus 12 passengers. And therefore, I'm looking at these two. If I add these two together, I should have 0.175, which is 17.5%. Now, probability of somebody in coach class, given that we already know that he checked one bag. So we need to find out what is the probability of those who checked one bag. And that probability in total is 0.45. And then what's the probability of those in coach classes? And that's in coach classes, check one bag, that's that. So it's 0.375. So this is simply 0.375 divided by 0.25. You should have 0.83 bar. So it's approximately 33.3%. Okay, finally, maybe I'll use black. Probability of those checked two bags given that they're first class. Again, first class, what's the probability there? It should be 0.1875. And then what's in first class, those checked one bag is how many? It's checked two bags. It's 0.1. It's right here. So it's 0.1 here. So this is simply 0.1 over 0.1875. So I have 0.53 bar. And that's 53% given with change, give and take. Okay, that's it. So as you can see, there's quite a bit to be learned in conditional probability. It can get quite fancy, but there are some patterns. In this video, we discussed two-way tables. We've now discussed frequencies, especially marginal frequency, how to break down the data together. So make sure you finish the second page of the homework so that you're very familiar with. We'll try to give you additional practices as well. All right, guys, take care. See you soon. Bye-bye.